Hello, my name is Anson Cutler. I'm a psychology student at Glendon conducting research for my honors thesis. The title of my study is The Role of Memory Color in Visual Attention. It focuses on a perceptual phenomenon known as the memory color effect, in which knowledge of an object's expected color influences how it's perceived. To date, most evidence for the memory color effect relies on subjective report methodologies, where participants describe their perception of a color. However, these studies are vulnerable to bias, so in this study, I attempt to provide evidence for the memory color effect using an indirect method, a series of change detection tasks to examine how memory color interacts with visual attention. So, to begin with, some objects have what's known as a memory color, which is the color they're known and expected to have. A classic example is that bananas are expected to be yellow, so their memory color is yellow. But not all objects have a memory color. Many man-made objects, such as books and coffee mugs, can be any color at all. There's no expectation. So, the memory color effect occurs when this knowledge of color influences how you see an object. For example, a grayscale photo of bananas might look slightly tinged yellow because they're expected to be yellow, and an orange heart shape might look more saturated red than it really is. You can see an exaggerated example of this in Figure 1. Some theorize that the purpose of this effect is to help us recognize objects in diverse scenes and lighting conditions, where oddly colored light sources might otherwise make it difficult to tell what color something is. The memory color effect is also theorized to be a top-down effect of cognition on perception. In other words, it's thought to be an example of a high-level process, color knowledge, having a direct effect on a lower-level process, which is sensory perception. However, it hasn't been easy for researchers to determine the nature of the memory color effect. Most evidence for it relies on research participants' subjective reports of what color they're seeing, which is a method heavily prone to bias. This has led to debate about whether the memory color effect actually exists or not. It also makes it hard to determine if the effect is truly top-down. This leads me to my present study. My first goal with this research is to provide evidence for the memory color effect that does not rely on subjective report. My second goal is to demonstrate that the effect is top-down, which is to say that memory color affects perception at or near the sensory level. I aim to do this by using a change detection task to assess how memory color affects sensitivity to visual changes in a scene. Change detection is a process of visual attention. If memory color does affect change detection, then its effect on perception is pre-attentive, meaning that memory color affects vision before we are consciously aware of what object we're seeing. The change detection task will also let me demonstrate the memory color effect without participants reporting on perceived color. My hypothesis is that speed and accuracy in the change detection task will be greater on trials where memory color objects are presented in unnatural colors, because these objects are unexpected and will draw attention more quickly than naturally colored objects, or objects that can be any color. The change detection task I'm using is the well-established flicker paradigm. In this task, participants see two images alternating quickly back and forth with a short blank interval in between. The images are identical except for the presence of one object, which seems to appear and disappear as the image flickers. The blank interval makes it harder to detect the change. Participants have to find which object is appearing and disappearing as quickly as possible, at which point they stop the flickering and click on where the changing object was. Their reaction time and accuracy is then recorded. This is done several times. As you can see, for this study I've used a blank gray panel with 28 objects on it. Half of the objects have a memory color, and half can be any color. There are 4 conditions relating to the disappearing object in each trial. In the natural condition, the changing object is a memory color object in its natural color. In the unnatural condition, it's a memory color object in an unnatural color. In the matched natural and matched unnatural conditions, it's an object without a memory color matched to the memory color objects. Here I have examples of 4 trials from the experiment with the target objects circled in red. The participants will do 10 trials in each condition for a total of 40 trials. Participants are 30 Glendon undergraduate psychology students. As the data analysis is still in progress, I'll present predictions of my results in this section. As I mentioned, I expect participants will be quicker to detect the changing object when it's a memory color object in an unnatural color. I don't expect to see any notable difference among the other conditions. I also expect participants will detect unnatural memory color objects with greater accuracy. Again, these charts represent my predictions only and are exaggerated for demonstration. If my predictions are accurate, it will demonstrate the memory color effect without any subjective report of color perception. It will also indicate that memory color, as opposed to object identity or color in general, has an effect on visual attention that occurs before the object reaches conscious awareness. This would mean that color knowledge does affect sensory perception in a top-down process. This concludes my presentation. Thank you for watching.